Today we are going to be talking about chemistry, and in this topic we are working with the periodic. I hope my spellings are correct too. Table. Okay. Now, when you talk about the periodic table, we're talking about to do with elements such as metals, non-metals, metalloids, periodic properties. You understand periodic laws and everything. So right now in the periodic table here, there is a man that first of all stated the periodic table. The periodic table was once stated by, and the periodic law, sorry, let's write it, the periodic law. The periodic law was stated by Henry Moseley, that's the modern. Normally before it was stated by who was the first person to state it? Mendeleev. Yes. Dmitri Mendeleev. The periodic law was first stated by Dmitri Mendeleev. You know, I'm not the person that is I don't understand their names very well, but anyhow I write their names. Please go and verify as a student. Dmitri Mendeleev. Now Dmitri Mendeleev stated the periodic law as, and so I can say which states that the properties of elements are a periodic function of its atomic weight. You see these words? That was what Dmitri said. Dmitri said the properties of elements are a periodic function of their atomic weight. When Dmitri stated this, everybody agreed with him in those days. Then somebody else now came and said, that thing you have stated, sir, is not the main idea. So let us reorganize the definition that you have stated. So the person who now stated the periodic table, which is known as the modern periodic law, was stated by Moseley. You understand? Henry. Please write Moseley. Yes. Henry Moseley. Henry Moseley said that the properties of elements, which states that the properties of elements are a periodic function of their atomic number. And if you look at these two definitions, they are almost the same, but Mendeleev is saying atomic weights. Alright? That's what Mendeleev is known for. But the modern periodic law is known for atomic what? Number. You understand? So, in these two definitions, though they were not the only ones that actually made an attempt to state the periodic law, but in your exam, that's what they will say. You understand? We only know two people, Dmitri Mendeleev and Henry Moseley. There are others that also talked about the periodic law. These persons are Wolfgang Dobrenia in 1817. He he was the first person to make an attempt to classify elements using what is known as the triads. That's what this guy did. Okay. Now, after Wolfgang did his own, Alexander was the first to identify periodicity in elements. He devised a spiral form of chart to classify elements called the telluric helix. That's what Alexander did. Then John Newman was the number 3. He proposed the idea of repeating octave of properties of elements before Dimitri now came and talked about the periodic law according to atomic weights. Then Moseley now corrected him by giving the modern periodic law, which is states that the properties of elements are a periodic function of their atomic what number. Now, knowing about these laws are very important for you as a student. You understand now? So, after learning about the law, there are some other things you need to know about the periodic table. Now, the periodic table, please take down. Hope you are done with this. Alright. Alright, the periodic table consists of groups and what? Periods. While the groups being vertical. You understand? So, there are horizontal periods and vertical groups. I'm going to be drawing us a very concise picture of the first 20 elements in the periodic table. Okay? So we will now be able to explain some of these groups and periods. Now you see the first 20 elements in chemistry will be drawn in this tiny table. Alright, so we have the group 1, the group 2, group 3, group 4, group 5, group 6, group 7, and then, accuracy matters a lot when you are dealing with sciences. So we have group 7. There is no group 8. You have what you call group 0. Now calling them G1, G2, G3, G4, G5, G6, and G7, and then G0. You understand? Now, if you look at this, I have, when you say something is vertical, it means it is running from top to bottom. Is that clear? This does not run sideways. This is vertical, top to bottom. Then horizontal runs from left side to the right side, or from right side to the left side. It's best to 20 elements in the periodic table. You have hydrogen, you have helium, then you have what you have now? Lithium, right? Beryllium. Beryllium is Be. Helium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and what? Calcium. There are more, but this is the first 20 elements. You understand now? Now you have to draw them. You know, it's good to know the first 20 elements with their symbols. Now the atomic, when Henry Moseley was talking about periodic table is a function. The property of elements is a function of the atomic number. He was talking about these things, you know. 4, 5, 6, 7, 8, 9, 10. And you have 11, 12, 13, 14, 15, 16, 17, 18, 19, and what? 20. Atomic numbers in elements are always written in the bottom, will I call it bottom right or bottom left now?
Bottom corner.
bottom corner, whatever. It's written in the bottom corner of the elements. Okay. Then if you look, well, it can be in the right side or the left side, depending on your textbook. Then the top of it always carries the atomic weights or the atomic masses. You understand? But elements are not arranged in periodic table according to their atomic masses. Rather, it's according to their atomic what? Number. Normally, atomic number of any element is the exact number where the element, how the element is located in the periodic table. So that one no get magic. Is that clear? Now, periodic table, you have vertical. How many groups do we have here? Group 1, Group 2, Group 3, Group 4, Group 5, Group 6, Group 7, and Group what? 0. It means that there are many groups? 8 groups, and how many periods? 7 periods. But we just gave you period 1, period 2, period 3, and period what? 4. There are 8 groups and 7 periods in the periodic table. 18 groups. Different kind of reactions to it. So let's talk about. I hope you have drawn this. Please draw it. Let's talk about the properties of groups and properties of what? Periods. The fast piece of groups. What are the properties of group? Number 1. The first property of group is that elements in the same group have the same number of electrons in their outermost shell. And number 2, the shells increases gradually. Hope you are writing, as we move down the group. You understand? So, and then I think if you continue to check in all groups, as you move down the group, the shell will be increasing. You want to have 1 shell, will go to 2 shells, next one will go to 3 shells, next one will go to 4 shells, just like that. But if you look at the electrons will just be, if you draw any of the group you draw, if you draw group 1, you have 1 electron in the outermost shell. If you draw, normally they are not reactive, so they are just normal. Then groups have names. Let's see the names of groups. Names of groups. So I have given you 2 properties of groups already. I hope you are done with this. I'm taking it off now. Names of groups. Names of groups in the periodic table. The first group here for group 1. I hope my spelling for group is correct. Group 1, the name is alkali metal. ALK, alkaline metals. You understand? While group 2 are called alkaline earth metals. You get now? Group 2, alkaline earth metals. It's called chalcogens. I hope my spelling is correct. CACOGENS. Please find out. It can be KA whatever, but it's chalcogens. Group 7 is called halogens. Halogens are also known as salt formers. Okay. Then group 0 are known as noble gases or inert gases. They call them noble because this may not the when something is noble, the thing does not really react. It doesn't really react to anything. You understand? So that's why they call them noble gases. Any elements found in group 0 are noble gases. So now let's talk about we have talked about groups and their names. Another property of group, if you know, elements in the same group are called co-geners. Co-geners, that's what they are called. If you have any question, you can ask me for the previous ones that we have done. Then let's talk about periods. Periods. What are periods? We say they are horizontal what now? Yes, horizontal rows in the periodic table. Yeah, write that down. Let's talk about properties of period. Properties of period. The first property of a period is that elements in the same period have the same numbers of shell. Then number 2, electrons increases gradually as you move across period. You know, since you have periods horizontal, you move across it, okay? And as you move across period, electrons will increase. Example, hydrogen has 1 electron, helium has 2, lithium has 3, beryllium 4, boron 5. Just like the electron continue to increase gradually. Okay? Now, since we are still dealing with the periodic table, let's talk about blocks of elements. I hope you are done with this. Blocks of elements. Blocks of elements. If you have done the quantum number, you understand this topic very well. There are 4 blocks of the elements. You have the S block. That's the S block. You have the P block. You have the D block. Then you have the number 4, the F block. If you remember Afuba's principle, can you remember Afuba's principle? Afuba's principle states that when elements are filling their blocks, they prefer to occupy orbitals of lower energy before moving into orbitals of what? Higher energy. Then you hear it is like 1s, 2s, abi? It was like this that we learned that time now. 1s, then you have 2s, 2p, and you have 3s, 3p, 3d, abi? Then you have 4s, 4p, 4d, and what? 4f. Then you now have 5s, 5p, 5d, and 5f, and so on. So he says it will feel like this, not so? Yes. Before it will now start feeling completely. So this is what helps us understand the Afuba's principle. Afuba's principle says elements will prefer to occupy orbitals of lower energy. 1s will be filled first, they go back, 2s loss. See, the electrons prefer to occupy orbitals of lower energy before moving into orbitals of higher energy. So if you understand this, you know why elements that are found in the s block, blocks of elements, you have the s block, the p block, the d block, and the f block. Okay, most transition elements are found here. Transition metals, they are found in the d block. So most times transition metals can behave sometimes like a non-metal, sometimes like a metal, because they have what they call partially filled d orbitals. Are you getting me now? Partially filled d orbitals. So while most non-metals, some of them are located in the p block, right? Some metals are also located in the s block. Okay, so that's for that. Then if you now talk about the f block, the f block, you'll be seeing metals like latinites and actinides in your periodic table. If you look at it very well, the bigger picture periodic table, you go down, you will see those ones. Those ones are latinites and actinides. So let's talk about some of the characteristics of transition elements, right? Characteristics of transition elements is not everything I have to put on the board. You see, they are located between group 2 and group 3. Group 2 and group 3 of the periodic table. Let's see characteristics of transition my transition S, is it S transition TRL, okay, element. So the first characteristic of transition elements is that they are located between group 2A and group 2A and group 3A. In the periodic table. Number 2, we say that they are all metals. Have you written that? Then number 3, they have partially filled d orbitals. I just said that before. They have partially filled d orbitals. You get? Number 3, I said they are all metals. Then number 4, they form colored ions. I told you before, stop using your devices. They form colored ions, and the colored let me use stroke complex. You grab ions. And then lastly, they have the ability to act as a catalyst. Number 5, which is my last one, I won't write it down. They have the ability to act as a what? As a catalyst. You get the point now. Now, what's a catalyst? Because of the word catalyst, what's a catalyst?
Catalyst is something that speed up the rate of reaction.
Something.
It's an element that speed up the rate of reaction.
It's a substance.
A substance.
Yes. A catalyst is a substance that not just speeds up, it speeds up and sometimes reduces. You understand? So we can say catalyst is a substance that speeds up or reduces the rate of a chemical reaction. Okay? And at the end of the reaction, they remain chemically unchanged. They are not affected by anything. Catalysts that speed up a chemical reaction are known as promoters. actually this word promoters is for biology. In chemistry, like this course we are doing now, they are called positive catalysts. While the one that reduces it, this one speeds up. The one that reduces the rate of chemical reaction are known as what? Negative catalysts. You grab this one, reduce or inhibit. You understand now? Then in biology, they are not called catalysts in biology. They are called enzymes. You understand the point now? They are called enzymes in biology. What are enzymes? Enzymes are organic substances that helps to increases or reduces the rate of metabolic reaction. Can you see the difference in the definitions? Now, the type of enzyme that helps to increase the rate of metabolic reaction are known as promoters. While the type of enzyme that help to reduce the rate of metabolic reaction are known as inhibitors. Is that clear? But in chemistry, they just call them catalysts and positive catalyst, negative catalyst. Is that clear? Alright, I think that idea has been conveyed. Right? Okay. So let's see some properties, periodicity of atomic properties, or properties of the periodic table itself. There are some certain things that you must know about the periodic table. What are they? Let's write it there. Let's call it periodicity of the atomic properties. So the first periodicity we must learn about is ionization energy. There are 5. Number 2, you have electronegativity. Number 3, electropositivity. Number 4, atomic radius or ionic radius or radii. Number 5, electron affinity. Now, these are some of the properties or the periodicity of atomic properties. These things have different effects in the periodic table. Some of them they do witchcraft something. Some go increase, some go decrease. Some they as you are moving in the periodic table, when you are checking it, some of them will increase and increase, some will decrease and increase, some will decrease. So you need to understand where the atomic, is it ionization energy that is increasing or decreasing? When you move down the group or across the period, what does it do? Understanding the definition for ionization energy helps you to now know, in the ionization energy principle of the periodicity of atomic properties, you will see that ionization energy, okay, if this is ionization energy, that means across the period it will do like this, and down the group it will also do like that. Is that clear? So when you get to know all these things, you will not be finding yourself wanting in any way. You get the point now? Alright, have you written them? Alright, let's talk about the first one, ionization energy. Let's talk about the first one, ionization energy. Did you pause it?
No.
What is ionization energy? What do you know about ionization energy?
It's the ability of an atom to lose electrons.
To what?
To lose electrons.
So we are writing it down. Ionization energy
The energy
is the energy required by an atom to do what now? To give out its outermost electron. Are you there? We say this is the energy required by an atom to do what? To release electrons. Not just ordinary electron, electrons from its outermost shell. Okay, it's called a valence electron. The energy required by an atom to release electrons is known as the what? Ionization energy. Note, something that we all must note is that ionization energy increases across the period and decreases down the group. Ionization energy increases across the period and decreases down the group. Now, I'm going to, for proper explanation, I'm going to draw the periodic table again. Don't worry, you don't need to draw it twice. I'm just the one drawing it for proper understanding, right? G1, 2, 3, 4, 5, 6, 7, and 0. Now, look at what we have here. In hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and then potassium and what? Calcium. Now, if you look at these elements here, when we say ionization energy is the amount of energy required by an atom to do what now? To release an electron. If you look at hydrogen have just one electron in its outermost shell when you draw the electronic configuration, the cloud. Now, this one electron that hydrogen has, giving that electron out is not a problem for hydrogen. That's why most elements in group 1, they are very, very well reactive. You understand? They are reactive elements. Then if you go to, let's use period 2 to make this explanation better. If you look at lithium, lithium has 1, 2, 3. Lithium is a very reactive element. It can easily give out its outermost electron. Now they told us that ionization energy increases across the period. Are you getting me? If beryllium wants to give, like we were taking this group, this period 2 as a case study, we said ionization energy increases as you move across the period. Look at it. This guy have 1 electron in the outermost shell. The energy to give out 1 million will not be compared to when this guy have 2. Look at it here. 2 electrons in the outermost shell. This guy have, like, let's say 2 million naira. Let's use money now. 2 million naira. Somebody asks for 1 million. Somebody asks for 2 million. What will you give? 1 million. That's it. The man wey you take give am 2 million. Talk of, let's go to boron. 1, 2, 3, 4, 5. How many electrons does he have? 3. 3 electrons in the atom shell. You expect boron to just give out the 3 electrons? You are supposed to be joking. Now, if you move across the period like this, the energy, the vigor, the mindset for these elements to start giving out their electron will begin to do what? To increase. Are you seeing that now? Will begin to increase. Why? Because this guy can easily give 1, but this guy to give is 2, he needs more energy. This one to give is 3, he needs more energy. When you get to group 4, say forget, carbon no dey give you anything. Instead of carbon to give to you, carbon will collect from you. In short, share with you. That's what carbon does. You see, when you are getting, you see, now the energy is tending to increase. The energy of the giving is tending to do what now? To increase. That's why we say across the period like this, the energy increases. But let's go down the group and see what happens. You have only 1 electron. To give out that 1 electron, your energy for giving will be decreasing. Rather, when you are here now, you have three. You have three. Somebody is telling you to give one. Wait this up. When you are here, you have how many? 11. They're telling you to come and give one. You know, when people have, they just want to keep on having. So as you are going down the group, what happens? The ionization energy is telling to the what now? To be decreasing. That's why you cannot compare the reactive nature of hydrogen to that of potassium. Neither can you compare the reactive nature of hydrogen to sodium. Are you seeing that now? So all these things are what makes the differences in the ionization energy of the elements. Is that clear? Now, understanding these statements and how these things work, you will see that we we could now understand why they say ionization energy increase across groups, across periods, and decrease down the group. Now let's take the second one. The second one there is I think electronegativity, right? Have you written about ionization energy now?
Yes.
Alright, electronegativity. Electronegativity of an atom is the power of that atom in a molecule to attract electrons. This time we are talking about the ability of the atom to do what? To receive. Okay? To receive what? Electron. That's electronegativity. Now, if you look at this group, this chart that we already have, let's talk about electronegativity now. And then you can make a conclusion by yourself on what is going on when you are dealing with look at it here. Electronegativity. We say electronegativity is the what now? The ability of an atom to do what? To attract, to gain, to receive electrons. Get the point now? Get the point now? Now, if this guy is the ability to gain, look at from here. Does lithium need electron from you? Let's use this line. Let's use period 3. Sodium, does it need electron? I told you when we did chemical bonding one time, I said the reason for chemical bonding is that elements want to attain stability. So sodium has 1 electron in the atom's shell. Instead of receiving, it will rather give. Magnesium has 2. Aluminium has 3. Silicon, instead of giving, it will rather share. Instead of receiving from you or giving from you, it will rather share. So in the middle of the table, they don't give nor receive. They do what they call sharing. Are you getting me? But if you come here, this one is what now? Silicon, this phosphorus, right? Phosphorus is a P now. Then sulfur, chlorine. If you now start moving down like this, you will see that these guys will now start doing what you call receiving. But I prefer to use group 7 when I'm talking about electronegativity. Group 7 elements are very reactive elements as well. They rather receive electron. Most times they are called the halogens because you see them as Cl minus, F minus, and so many other minus, Br minus, and the rest. So you know that all elements in group 7 are needing 1 electron to fill up. If you draw their electronic configuration, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I correct? 10, yes. 11, 12, 13, 14, 15, 16, 17. They require 1. I think I drew for chlorine now. This chlorine require 1 electron. So the ability for them to receive is from here. So if you look at the periodic table very well, there's a conclusion we can now make, right? So what do we say electronegativity is? We say electronegativity is the ability of an atom to do what? To receive electrons. Abi? So in a nutshell, we can say that electronegativity increases across the period and decreases down the group. Electronegativity increases across period and decreases down the group. So as you are moving in a period like this, their ability to start collecting is to start increasing. Are you seeing that now? Somebody that collected 4, or somebody that collected 5, somebody that collected 1, are they the same? No. It increased across period and decreased down the group. Is that clear? Now, that's the conclusion we can make for electronegativity. Then for electropositivity, this is a measure of the tendency of atom to lose electrons. So that's the next one. Electropositivity. You say it is a measure of the what now? Of the tendency of atoms to do what? To lose electrons. Please write it down. This is what you are writing. Definition and their reasons. So electropositivity is a measure of the tendency of an atom to do what now? To lose electrons. So if look at this. When we did ionization energy was the energy that is required to give. Abi? Electropositivity and negativity was the ability for an element to receive. Electropositivity is the ability of an element to do what? To lose electrons. Not so. Electropositivity and ionization energy, they are almost the same. Is that clear? And if you look at the note here, electropositivity decrease across period and increase down the group. You know one thing in chemistry, when you are giving electron, what happen? You become positively charged. Abi? If you look at all the last group, the last periodic table I drew, look up please. The last periodic table I drew, you see that when you are moving like this, the positive nature of the elements changes. When you get to carbon and the rest, instead of seeing positive, now start seeing negative. So we say electropositivity decrease across period and increase down the group. Is that clear?
Yes.
Then let's see the next one. The next one is atomic or ionic radius. What is it? It is a measure of the size of the atom to the distance between the nucleus and the outermost electron. Now for ionization, for atomic radius, let's use group 1 element. Group 1 element, hydrogen is from group 1, right? What's the atomic radius? From here to here. The next element is lithium. Lithium has 2 shells. From here to the outermost electron. So we have put electron here. 1, 2. The outermost electron is here, right? Then let's go to the next one. The next one should be sodium. Sodium is Na. You have 1, 2, 3 shells. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Then 1. Are you seeing it?
Yes.
The distance from the nucleus to the outermost electron. If you see, as you go down the group, what's happening? The atomic radius is doing what now? Is increasing. You cannot compare this single shell and this shell with this one to the third shell. Are you seeing it? As you are moving down the group like this, atomic radius is what? Is increasing. But when you are moving across periods, look up. When you are moving across periods like this, because you are feeling, see it here, because you are feeling an electron into the shell, what happens to the shell? The shell will be shrinking.
Yes.
Is that clear? It will be shrinking. So we say across periods, atomic radius or ionic radius will do what now? Will decrease. But down the group is to do what? It will increase. Is that clear now?
Yes.
That's the explanation for atomic or ionic radius. Then let's see the last one, electron affinity. Electron affinity electron affinity. Now what does electron affinity talks about? We say this is the energy released by adding an electron to a neutral atom in the gaseous state. Electron affinity is the energy released by adding an electron to a nucleus atom in the gaseous state. Sometimes I use the word the law of the element acts for themselves is what electron affinity is all about. Let me give you a breakdown. Here we said while ionization energy deals with the loss of electrons, electron affinity deals with the gain of electrons. Electron affinity is the energy released when a gaseous atom gains an electron to form a gaseous negative ion. When a negative ion forms readily, a lot of energy is given off. That is, electron affinity has a large negative value. Generally, electron affinity increases across the period from left to right. If it increases across period, it means it will decrease down the group. Is that clear? Now, the electron affinity increases with decrease of atomic radius across the period and decreases with increase of atomic radius down the group. This is because atoms with similar atomic radius tend to have a stronger attraction for electrons and to form negative ions more readily. Now, listen to this statement. This is because atoms with similar atomic radius tend to have what? A stronger attraction. Now, what this means is that we have ionization energy. Let's say periods, groups. So we see here ionization energy increase across period and decrease down the group. And the next one is electronegativity. Now for electronegativity, it says it increase across period, decrease down the group. And the next one is electropositivity. This one decrease across period and increase down the group. And the next one is atomic or ionic radius. This one, it tends to atomic or ionic radius decrease across period and increase down the group. And the last one is electron affinity. Electron affinity tends to increase across period and decrease down the group. Now you can see the summary of what we have been explaining under the periodicity of elements. I hope this gives you a better understanding.